Okay, as I promised in the last video, we're going to look at finding the slope of tangent line at a point. Okay, so the point 3, -4 is right here. If I go over 3 down, -4 is going to be right here. So we want to know what the slope of this tangent line is right here. It's supposed to go through at that point right there. So it looks like it's going to be a positive slope, and we're going to use implicit differentiation to find that. Okay, so the first thing we're going to do is I'm going to take x squared plus y squared equals 25. Okay, I'm going to differentiate with respect to x, and I'm going to differentiate both sides. So I've got d over dx. Okay, so then I'm going to take the derivative of x squared plus y squared, and I see I'm going to need to pay attention to which variable I'm differentiating with respect to, and I'm going to take the derivative of 25. Okay, when I take the derivative of x squared, that gives me 2x. When I take the derivative of y squared, it's going to give me 2y, but then I need to remember that when I differentiate with respect y with respect to x, I need a dy dx. Okay, and then I know that the derivative of 25 is 0. Okay, now I need to solve for dy dx. So if I take 2y dy dx, then that is going to equal -2x. Okay, again, I want to isolate dy dx. So to isolate dy dx, I'm going to say that dy dx equals, divide both sides by 2y, so I'm going to get -2x over 2y. Okay, so that now is going to say, I can divide by 2, so I'm going to say the derivative of this function, or the slope of the tangent line, is take the negative of x times y. Okay, so now we're going to use that fancy notation that we've seen before, where I take dy dx, and I'm just going to put a little line through it like this. I'm going to evaluate at the coordinate 3, -4. Okay, so that means take dy dx, which is this formula right here, and plug in 3, -4. Well, I have a 3 for x, so I'm going to plug in -3, and then I've got y to be -4. So I have a slope of 3/4. Okay, it's a positive slope, so it's saying if I go up 3 and then over 4, so 3 over 4 would give me the slope of the tangent line. Okay, which is great. So again, this formula right here would give me the slope for all points. Okay, so this is for all points. I could plug in, I could look at what's the slope of this line, and I could plug in my x and my y, and it would give me what the slope of this tangent line is. I could also go up here and plug in the slope of this point, plug it in, it would give me the slope of this line, and over here. Okay, the only points we have to be really careful about is right here, because it is undefined. So the only points where this formula won't work, okay, is when the slope's undefined. So we can say that dy equals dx equals -x over y is a formula. Okay, it's a formula that will work to find slope. Find the slope of the tangent line. And we're going to add a point here, except when x is equal to plus or minus 5. Okay, and that's because the slope is undefined at those 2 points right there. Okay, so I just want to show you another way to do this exact same problem that utilizes our skills with our previous work and how we're going to get the same answer. So let me show you something here. If I take x squared plus y squared equals 25, so to start this problem off, I'm going to try to do it with the rules we've done previously. So I'm going to get y equals by itself. So I'm going to subtract x squared from both sides. So y squared is going to equal 25 minus x squared. Okay, then I'm going to say y is equal to plus or minus the square root of 25 minus x squared. Okay, so I'm just going to look my graph in the previous problem. When I was looking at this graph right here, 3, -4 was on this half of the circle because this equation right here is going to graph. The plus is going to give you this half of the circle up here, and the minus, okay, is going to give you this half of the circle. So what I want to do here is just work with the minus. So I'm going to work with y equals the minus the square root of 25 minus x squared. Okay, so then I'm going to be able to say that this is y equals the negative of 25 minus x squared to the 1/2. Okay, so now I'm going to take the derivative. So I'm going to say the derivative is going to be negative 1/2 of 25 minus x squared. 1/2 subtract 1 is going to give me negative 1/2. Now chain rule says I need to take the derivative of the inside. So the derivative of the inside 25, the derivative of 25 is 0, but the derivative of this is negative 2x. Okay, so then in the next case when I go to clean this up a little bit, the 2's cancel. This 2 and this 2 are going to cancel. The negative and the negative are going to cancel. So I'm going to be left with x times 25 minus x squared to the negative 1/2. Okay, and in the next case, I'm going to clean this up a little bit. So I'm going to say this is going to be x over 25 minus x squared to the positive 1/2. Okay. All right, so there's your formula. That is your derivative of y with respect to x. Okay, so now let's think about what we wanted to do here. We wanted to know when x is 3, because up here we're looking at the point, the whole problem and the last problem is what's the slope of the line when x is 3, y is -4. So I'm going to take this value right here, which is x over 25 minus x squared, all to the 1/2, and I'm going to evaluate it. I'm going to put the little bar here. I'm going to evaluate it when x equals 3. Okay, so to do that, I'm going to take 3 over 25 minus 3 squared is 9 to the 1/2. Okay, which is going to give me 3 over 16 to the 1/2, which is going to give me 3/4. And if you remember, 3/4 was what the answer was that we got on the previous page. 3/4 was the slope of the line that I got right here. So you can use implicit differentiation, but in this case, we are also able to use our power chain rule.